everyone. My name is McCarthy. I'm an assistant professor at the University of South Carolina School of Medicine, Columbia. And with me is Dr. Ashley Pitzer from Vanderbilt University. She is a finalist for the Stephanie Watts Career Development Award. Congratulations, Ashley.
Thank you.
Do you mind starting us off by telling us a little bit about your background and then what's led you to this project pitch that you're going to be giving us this afternoon?
Right, so as you kindly introduced, I am at Vanderbilt University. I'm a research instructor in the Division of Clinical Pharmacology. And during my grad school work, I mainly focused on the role of the NLRP3 inflammasome in early stage endothelial dysfunction. And so when I was looking for postdoctoral positions, I stumbled upon my mentor, Annette, who is focused on salt-sensitive hypertension, and just collaborating between my expertise of the inflammasome and her expertise in oxidative stress and salt-sensitive hypertension. It kind of felt like a perfect match, and that kind of teed me up for my postdoc work, which mainly focused on the NLRP3 inflammasome in antigen-presenting cells and how that modulates or plays a role in the development of salt-sensitive hypertension.
Very interesting. So do you look at purely immune cells, or do you look at immune cell infiltration into the vasculature or the kidneys or the brains as part of your research? Right.
So right now, focusing is mainly just looking on the impact of salt on antigen-presenting cells. And so work that was done previous had looked at the role of an epithelial sodium channel ENaC, which is primarily found in the kidney, but we found that it's also in antigen-presenting cells, meaning that they can respond to salt. So the question is how is that happening? There has been work done that looks more into infiltration into, per se, the kidneys and the vasculature. However, my work is mainly looking more mechanistically of how salt is impacting antigen-presenting cells.
So Ashley, how is that work leading up into your project pitch that you're going to do today, and then like your future lab?
The work I had done leading up to this project pitch and truly my starting my journey towards being an independent investigator is that we found that this ENaC-dependent mechanism by which salt activates antigen-presenting cells such as dendritic cells not only leads to inflammasome activation, but also the formation of these highly reactive products of lipid peroxidase, these isolog-adducted Isolg-adducted. And so one of the major questions was how are Isolg-adducted and the inflammasome related? And that's truly the stepping off point into looking more as Isolg-adducted adducting to histones as an epigenetic regulator of inflammasome components, and then broader strokes of just how are Isolg-adducted histones modulating gene transcription that is affecting salt-sensitive hypertension as a whole.
Well, so you really wanted to study the genetic mechanisms by which this, like a salt-immune interaction could be going into.
Right, and more importantly is using it as a translational study, because we've looked at both in humans as well as in mice. Humans is more as of correlation and looking at phenotype salt-sensitive and salt-resistant patients, but of course using mice to look at more mechanistic of how is this happening. So that's the important thing is the translational aspect of it, and just understanding the differences in hypertensive people who are highly sensitive to salt and those who are highly resistant, and perhaps as a generational thing. So that's more further down the line, but.
Well, that's really exciting stuff, and I'm looking forward to you launching your lab in the future, maybe with this Career Development Award under your belt. But congratulations again, and thank you for your time this afternoon.
Thank you.